Hey guys, we're going to take a look at a problem that cannot be factored by grouping, but it does say to solve the polynomial. So we're going to look at using the rational root theorem and then also how we can use the calculator to help us out. So in the rational root theorem, we need to identify both the constant, which is 24, and the leading coefficient, which is 1, and create a possible list. So because this is a 1 here and not any other number, we can basically just take the factors of the constant, but we're going to take either the positive or the negative of each of those. So again, 1 times 24, and I'm just going to list them in order. So 1, 2, 3, 4, 6, 8, 12, and 24. And we're going to use these to help us get a 0 for the problem to help us solve. So I'm going to choose a number. It doesn't really matter which number you choose to begin with. I would probably stay away from 24. But I'm just going to choose -2. And so if we use -2 and do synthetic, we put -2 into the house. We've got all of our coefficients from the polynomial we are trying to solve. And we're going to go ahead and multiply and add. Bring down the 1, multiply, add, multiply, add, multiply, and add. And here you can see we don't get 0. So because we don't get 0, -2 does not work within this problem. It is not one of the zeros. So just for the sake of trying it, I'm going to try its opposite, 2. So we've got 1, -1, -14, and 24. We bring down the 1, multiply, add, and go through this whole process until we get to the end of the problem. And actually +2 does work here in this problem. So this 1, 1, and -12 represent our new polynomial. That's x squared plus x minus 12. And again, the whole problem is trying to solve, so we need something that is x equals as an answer. But we want to factor this first. Two things that multiply to be a -12 and add to be a +1 are going to be a +4 and then a -3. If we were to set each of those equal to 0, we would get -4 from this first parenthesis, 3 from the second, and then 2 from the number that we used in synthetic originally. And again, we should have 3 answers, because if you look back at the original polynomial, x to the third minus x squared minus 14x plus 24, the degree is 3. That's telling you how many answers you should get in total. So if we have the ability to use a calculator, we can do that. And if you were to graph this polynomial on the calculator, you would see that it would cross at -4, 3, and 2 on the x-axis. And when you see those, all you have to do is pick one of those values, plug it into synthetic, and continue your work. But just make sure that you are showing this amount of work. Again, these would be the zeros where it would cross on the real axis, -4, 3, and 2. As long as you pick any one of those, and you should get 0 here as a remainder, and keep working through the problem.